All right, y'all. So we're gonna work on question 5 of the same test 2019 AP Calc exam review. I'm gonna walk through part A, B, and C for you guys today. All right. So here we have a volume / area problem. No calculator, right? And these can actually probably be the trickiest ones. There's a lot of calculation involved without the calculator, so you have to be really careful. But so let's see. Let R be the region enclosed by the graphs of g of x equals -2 plus 3 cosine pi over 2x, and h of x is equal to 6 minus 2 times x minus 1 squared. The y-axis and the vertical line x equals 2 as shown in the figure above. All right. Now find the area of R. Okay, so first when we're finding areas, let's make sure we know which function is the upper bound and which function is the lower bound. Oh shit. I guess I better have uh wow, everybody wants to talk to me right now. Love you, Jalen. So basically, sorry, back to the topic at hand. So here, you have to figure out which function is the upper bound and which function is the lower bound, because what we're going to do is essentially we're looking for integrals or areas under the curve, correct? So if we find the area under this curve, right, from the bound 0 to 2, because that's our boundary here, our x boundary is 0 to 2, right? If we found the entire area under this curve, it would be all of this, even this empty space that we don't want. We want the area between the two curves, right? But if we take also the integral from 0 to 2 of this function, and we subtract that from the area underneath the upper function, we're going to get this area in between, right? So we have to figure out which one is the upper bound and which one's the lower bound. So the function here, let's see. Honestly, I'm not that good with trigonometry, but if we use our intuition here, we can kind of figure out which one's which. So let's start with the one that doesn't have trig involved. And we see that it has a 0. So if we plug in 1 here, let's just plug in 1, right? This is going to be 0, right? And so our x value will be 6. Let's look at 1. This looks to be about 6, and this is definitely not 6. So we know that this is h of x. H of x is our upper function. And g of x is going to be our lower function by default, right? So now, in order to find the area between these two curves, what we essentially need to do is find the definite integral of, which one was the upper function? H of x, right? H of x minus the definite integral of g of x, which can be simplified to, of course, 0 to 2 h of x minus g of x. So, as we can see, this is a little bit more easy to work with, but this is the simplified form. And so we see h of x. Oh my god, I can't find this goddamn cursor. They make it so difficult, they really do. As we can see, h of x is going to be equal to 6 minus Okay, yeah, we got that. So this one's going to be the easier one. First, we've got to find the antiderivative and then plug in, so let's first just find the antiderivative of this. This will be 6, and then because we just have a single number here, we just add the x. And then here we have a constant times x minus 1 to the second power, which to the second power plus 1 would be to the third, right? Because we want to add a 1 to this exponent right here. And then we bring this 3 down into the denominator of the 2, because we're going to take the inverse of 3, which is 1/3, and multiply that by the coefficient. And this is your antiderivative. You would put plus c if it wasn't a definite integral. But here we have a definite integral. So we have 6x. We have all this right here. But then since we have a definite integral from 0 to 2, what we do is we plug in to our x values that we found here, right? So this is our antiderivative, and we plug in our x values starting from the top one first. So we plug in 6, and then we plug in 2 for x, right? Minus 2/3 times 2 minus 1 squared. Oops, here. Oh, sorry, y'all. I'm slow. This is difficult. Let's see. So the definite integral from 0 to 2 of h of x, our higher function, is this right here. And then we do the same thing, plug in the x value, but for the lower bound. So that'll be 0 minus 6, 0 minus 2/3 times 2 minus, times 0 minus 1 squared. All right, so that is, we're not going to simplify that just for this time's sake of the video, but this is your definite integral for h of x. And now we do the same thing for the definite integral of g of x. Now this one's a little trickier because we have the function -2 plus 3. So the function -2 plus 3 cosine. When you see that trig, that's how you know it's a little harder. Pi, and I believe it's pi over 2x. So as we can see, yeah, pi over 2x, perfect. All right, so as you can see, this is going to be easy right here, finding the, what's it called, antiderivative here. The antiderivative of -2 is just -2x. This is where it gets tricky. So we want to find the antiderivative of 3 cosine pi over 2x. And we know we're going to have to use u substitution. And, obviously you want to leave the cosine alone. 3 is a constant. Let's make pi over 2x our u here. So u is equal to pi over 2x. Oh yeah, guys, and this is a rookie mistake. Make sure that you put dx for your integrals. because they will take points off for that. You get the gist. But just make sure you put your dx after these when you get your, yeah, because they probably will take points off if you don't put that there. It's a little thing. See, I forget that because I'm just trying to get to the calculation. But so let's go. God damn, this cursor, bro, gets so small I can't see it. All right. Now we have u as pi over 2x, and if u is equal to pi over 2x, then what's the derivative of u? Well, that would just be the derivative of pi over 2x with respect to x, which would be pi over 2 dx. Right. So substituting this into our, let's do this over here so that we get this answer down here. Substituting this down, the u into the equation gives you 3 cosine u, and then solving for dx here, or here, let's do times pi over 2 dx. And since we want to just have our dx alone, we have to multiply the equation by 2 over pi, right? Because we just want the dx by itself. We don't want to have a complication over it. So then we're just going to have, let's bring that over here with the 3. So we'll just have 2 over pi here. That means we are good to go. We can get rid of that and just have the dx there. And so now we just have the u here, and we're solving for, we want to get the antiderivative of cosine u here. And we know that the derivative of, so that just means what's the derivative of what will equal cosine. And we know that the derivative of sine equals cosine, so the antiderivative of cosine must be sine. So let me just erase that and write sine, right? Because that is our, this thing's going to piss me off. Sine right here. Okay, and this will cancel out to 6. So altogether, after we use our u substitution, we have 6 over pi sine, and now we're going to substitute the pi over 2x back in for u. So we have sine pi over 2x dx. And now we have to find, now we want to find the definite integral, because this is our what's it called, our antiderivative. So we want to find here, so remember what we do, right? So we plug in our upper bound to our antiderivative, which would be 2 plus 6 over pi sine sorry, this is tedious. I'm telling you, this mouse is going to be the death of me. Almost wrote x. This is going to be a times 2 minus negative 2 to this times 0. Ooh, that was ugly. Plus 6 over pi sine pi over 2 times 0, right? Which essentially will just be, okay. And now I'm not going to simplify this whole thing for time's sake, but you know, we want to get, essentially we want this, right? Which equals to this. And we just got our definite integrals for both of these by taking these. So what we have to do is we take this whole expression here. Oh shit. This whole expression here, and we subtract from it this whole expression. All right. And yeah, for time's sake, I'm not going to. Here's what I'm going to do though. Make sure when we are, first of all, this is going to cancel. So make sure just for this, you make sure that you know your unit circle. And these ones are pretty easy because you're going to have to figure out what sine of pi is. But if you look on the unit circle, I'm not going to pull it up right now, but sine of pi is going to equal to 0. And this obviously will cancel to 0, and sine of 0 is also 0. So these are just going to cancel out to 0. So they made it a little bit simpler for you. But just make sure that you know your unit circle, because sometimes they throw in a little bit of wacky ones in there. You're going to need to know because these are no calculator, right? So you're going to have to remember what that value of sine, cosine, maybe tangent is going to be. But they're probably going to keep it pretty simple for you. They're not going to give you like hard ones. They're probably going to give you the ones, I'd say pi over 2, pi, 0, 1, or 3 pi over 2. Those are probably the most common places on the unit circle. They're going to want you to know what sine and cosine are at those values, but I would just memorize all of them just to be safe. Okay, now I'm going to do a new file here because we are done with that question. Oh, sorry. And when you solve this, you should get 44 over 3, or 44 pi over 3. Wait, sorry. Let me go back and look. 44. No, it should just be 44 over 3 because the pi's are going to not be there. So sorry about that. It's going to be 44 over 3. And let me know if you have any questions about that. But, oh my God, bro. But yeah, I didn't want to do the whole calculation because, yeah, 44 over 3. I didn't want to do the whole calculation because it's just going to take forever. So let's go to the next one. And yeah, maybe I might have rushed over that one a little bit. So if anybody has questions, you could private message me. Let me check if anybody has questions right now. Mrs. Manassian, math teacher, shut up. Please post these on YouTube. Okay, maybe. Someone is finally learning. Hi, Mrs. Sway. Hello, baby. So why are you doing this again? I'm doing this because a lot of kids don't have their teachers at their disposal, and the AP test is coming up, so I just figured I'd help out because I took this class a few years ago. All right, region R is the base of a solid. For the solid at each x, the cross-section perpendicular to the x-axis has area A of x is equal to 1 over x plus 3. Find the volume of the solid. All right, so this one is the easiest question in the entire segment of number 5. So basically, if it gives you the area function, right? So each area perpendicular, this is the base. R is the base. And so basically for each cross section of R perpendicular, so like each slice vertical, there's an area. And each area is going to be different, right? Because the base is either bigger or smaller depending on the function. It's going to vary on what your x is. And so we want to sum up all of these slices given x. And our x boundaries are 0 to 2, right? So let's just set up an integral, a definite integral of 0 to 2 for the function a of x, which is going to be equal to 1 over x plus 3. All right, and we know that when we see these kind of equations with a numerator and a denominator, we know that this is going to be a antiderivative of a log function, or the antiderivative of these are going to be a log function, and log functions have this form. And so we know we can say x is x plus 3, or we'll say I guess we can use our u substitution here, but I mean it's a little bit intuitive, but I'll just still do the u substitution so you know. Let's put x plus 3 as our u and our du. Oh, and make sure you put your dx here. Keep forgetting that. Maybe. Du is equal to 1, right? Because this is a constant, and 1 is going to be the derivative of x. So d of u is equal to 1 dx, so we don't have to worry about that. So we would have here du over u. Oops. Sorry, I didn't explain this very well. Let me go back. So we know that the derivative of a log function is going to look like this, right? So that means, so this is a log function, this is its derivative. Its derivative will be the derivative of x if x is in the denominator, right? So now we have u in our denominator, and we have our du on top, right? So that means we have our, we'll plug u back in. Obviously, and then we have our 1, which means that this would equal to, this would equal to ln of u, right? Because we're following this format here. And when we plug u back in, we get ln u over 1 dx, right? And so now, now we know that ln x plus 3 is going to be our antiderivative. Sorry. Yeah, I didn't explain that very well. Sorry, I was kind of all over the place trying to figure it out myself. Basically, yeah, du over u, and then we get the function ln of u as our we get the function ln of u, right? Because it follows this format. Dx over x is equals ln of x. So if we get du over u, that must mean that the antiderivative is ln of u, correct? And then we just plug in u for ln is equal to x plus 3. Sorry if I confused you guys on that. You can always ask me questions, but this will be our antiderivative. And now we want to plug in, we want to do the same thing, right? For we want to get our definite integral. So we're gonna definite integral of a of x we want to get ln 2 plus 3, right? Because we plug in the upper bound first, and then minus ln, plug in our lower bound for x here. And because this is no calculator, you can really just leave it in its unsimplified form. So this is going to be your answer for the area or the volume with when each cross section perpendicular to the x-axis has an area of 1 over x plus 3. So it'll be 5. This will be your answer right here. And that's what I'm saying, because it's not calculated. If this was a calculated question, you'd have to simplify all the way. but this is not calculator, so this is fine. And that's a 5, by the way. I just wanted to cross out that 2 that I started putting. So this is 5. Natural log of 5 minus natural log of 3. And I hope nobody really got confused because it took me a while to get through an explanation of this because I made a mistake here. Yeah, so if I confused you, I'm sorry. Let me know. And let me see questions. Forgot a lot of this. I did too, honestly, so it's refreshing, I guess, to go back to it. Okay, this is going to be the hardest question we are going to do here. Right, but do not evaluate, so that's what's, this actually, you just have to use your intuition. Right, but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals x, or y equals 6. Okay, so I drew this out for us, right? So if h of x is, this is the, and sorry guys, this is not to scale, so this should like be perfectly even from this y equals 6 from this upper bound function, but I'm sorry, I don't have enough room on the page. So basically, we're saying that we're taking this this solid, right, with the boundary 0 to 2, and this is our upper bound h of x, this is our lower bound g of x, right? We're flipping it over the line y equals 6. So here is, so we reflect it perfectly over the line. So now this is our h of x, right? Because it's rotated, it now becomes on this part of the, on this reflection. So this is going to be our reflection solid. This is original r, right? This is our reflection. This h of x is now going to be the function on the bottom, and this g of x is going to be the function on the top. I'll explain to you why that's important now. So we have this, right? And they want us to find the volume of the solid generated when we flip this over, right? But we know because we didn't flip it in like perfectly over the y-axis. We didn't flip it perfectly over the y-axis. We flipped it over a horizontal line, right? So there's going to be space in the middle here. You see this space? This I'll draw it a different color. This space right here. That's going to be space, and it's going to change the length of the space, if you will, is going to change as the functions change, right? It's going to change, right? So we know we're going to have to write an integral. So we're going to have to use the washer method. And the washer method basically states that if you want to find a solid that's generated from a reflection, right, and we already know our boundaries, it's 0 to 2, you take the integral of, so we have washers here. Let's say we have washers. This is the outer radius of the washer here, right? And it's going to be, the radius is only half of this, obviously. So this is the washer here. This will be the radius, right? Right here of the washer. Sorry, these should be equal, the lines between y equals 6 and the upper functions, or the upper and lower g of x, the two g of x's right here. It should be equal lengths because it's a radius, but that was just bad. It's not to scale because of my computer screen. So this, let's say this is the length of our outer radius, right? So this is the length of our outer radius, and this is our inner radius. This is the space in between. This is the space in between, the empty space. That's the space we don't want to count. So when we're using the washer method, you have a boundary, right? Let's say x to y. And we're going to take the, so we're going to take, it'd be pi of r squared, or outer, right? Radius squared outer. And we make it, this is an integral because the value of this radius is going to change as the functions change. And then we have pi radius inner squared, right? Because we don't want to count that middle space. And we're using pi r squared because that is the area of a circle, and these are circles, as you can see. They're washers, but we don't want to count the middle of the washer. This is the middle of the washer. This is the empty space. Okay, so now we can plug in a value for, so we know what our radius outer is going to be, right? That's going to be the length. So let's look here, right? Let's look at this right here. This is the distance from y equals to 6 to g of x, right? Because y equals 6 to g of x, that's the whole radius of this outer washer. So we have, and also we can factor out pi here. So we have pi, and we know our boundaries. We can plug in for x and y, that this is 0 and 2. And so we have our outer radius is going to be 6 minus g of x. Because we don't have to, they just said write an integral. We don't need to solve it or anything, right? And this is our radius, outer. Minus, we don't want to count that empty space in between, so we have to do the inner radius. And that's going to be, as you can see, the distance from y equals 6 to both of these h of x's, which will be equal distance. So y is equal to 6 to h of x, which is going to be the distance of 6 minus h of x. And don't forget this part, dx. And that is the integral that you set up. This might have been the most confusing question, I don't know. But it's nice that it doesn't ask you to solve for the volume generated between the reflection, or the volume of the solid that's generated when you reflect the r over the y equals 6 line, because that would just ass. But yep, that's your answer there. Yep. And there you have it. That is FRQ, and I think number 5. And yeah, let's make sure that our answer was right. Yes, we were correct. Sweet. Yeah, so any questions, hit me up. But that is FRQ question 5 of the 2019 AP test. Questions? Nope. RT.